short form. So in that case, there's no need to using a calculator or table. So these special angles will help you through in putting your answer in short form. Now, before we solve these two questions, we need to quickly look at how can you remember all these angles, these special angles, without your calculator and without your um, table. Now, there's what we need that we need to memorize. The first part, we have two triangles that can be used in determining these special angles. So the first one that contains 45 is isosceles right angle triangle. So in isosceles right angle triangle, you are having angle 45 of which you are having here as 45 degree. Because it's a right angle, you have it as 90 there, and this is 45. So you just have to memorize this triangle, of which here is 1, you have one here, and here is root 2. Now, how do you now bring out this special angle from here? And don't forget, when you want to deal with this, you have to remember what is called socatua, 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 socatua. So now I'm going to be using this now in dealing with each of them. Now, looking at this now, when you look at this, if I want to find sine 45, sine 45. So don't forget, from this socatua, S is standing for sine, YC is standing for cos, and this is standing for tan. Therefore, here this O is opposite, H is hypotenuse, A is adjacent, hypotenuse, opposite, adjacent. So now sine 45, this is sine and it is opposite hypotenuse. So the angle is standing here. Either if you choose this or this, is going to give you the same answer because they are the same angle. So if I'm standing here now, since I'm dealing with sine opposite hypotenuse, to this angle now, here is opposite, and the longer side of this right angle triangle is hypotenuse. So opposite hypotenuse. That gives 1 over root 2. Now, 1 over root 2. Then if you look at cos, if I should find cos 45, what will I be having? I will be having adjacent hypotenuse. So to this angle now, here is the adjacent. So adjacent hypotenuse is 1 over what? Root 2. That is why if you use your calculator, press cos 45, it's going to give you the same answer as sine 45. So the last one now is tan 45. Tan 45. And tan 45, if you look at it from here, we are having opposite hypotenuse. So to this angle, this is opposite, opposite adjacent. To this angle is opposite adjacent. If you are looking at it from this angle, opposite adjacent. So which means we are having 1 over 1. This is adjacent is 1, opposite is 1. So which is equal to 1. So this is whenever you are solving a question requiring or requesting you to leave your answer in short form, and you're having the angle as 45. So you can, instead of using sine 45, you can use a 1 over root 2 like that. So this is one of the angle. I told you is two triangle that you can use in solving your special angle. This triangle only contains 45. Now there's another one that we call this triangle, which is we have an equilateral triangle. Equilateral triangle, equilateral triangle, which can be this equilateral triangle. You can have it as this. This is just my this equilateral triangle. Here is equals to here is equals to here. This line or the line. So now, if that is the case, here. So if that is the case, you call this place 60 degree. This is 90. Here is 30 degree. Here also 30 degree. Here is 90. here it was 60 degree. So this line from here to here is root 3. Here is 1. Here is 1. You have here as 2. You have here as 2. You just have to memorize this two triangle for you to be able to deal with all your special angle. Now from here now, if I'm to look for sine 45 from this triangle, I'm looking for sine 45. Sine 45 will gives sine 45 will gives us, look at it, sine 45. Sorry, I'm looking for sine 30 rather. Sine 30. So from this triangle now, this is 30 to this angle now. Where is the opposite? Don't forget opposite hypotenuse. This angle is facing here. This is the opposite and hypotenuse. So we're having 1 over 2. So if I am to look for sine 60 degree, now where is 60 degree in this triangle? You can use this one or this one, get the same answer. To this angle, looking at this place, opposite hypotenuse. This is opposite hypotenuse. That is root 3 over 2. Then to look for cos 30. Cos 30, how do you get that? Cos 30, here is 30. You could use this or this, you get the same answer. Here is 30. Where is the adjacent? Adjacent hypotenuse. So to this triangle, to this angle, here is the adjacent. Why this line is the opposite hypotenuse. So adjacent is root 3, hypotenuse is 2. So which is root 3 over 2. Then cos 60 now. What will cos 60 gives us? Cos 60 will gives, if you look at it to this angle, where is adjacent? Because we are still following adjacent hypotenuse. So here is the adjacent and here is the hypotenuse. So 1 over what? 2. The adjacent is 1, the hypotenuse is 2. So now if you are now looking at tan 45, tan 45. So how do we deal with this? How do we deal with this? We have tan 45 and our frontal, we're having opposite adjacent to, sorry, should be tan 30, tan 30. So opposite adjacent to this angle now, this is opposite and here is the adjacent. We're having it as 1 over root 3. Now, if we now look at tan 60 degree now, to this angle, don't forget opposite adjacent. To this angle is, where is our adjacent? 1 is our adjacent and here is our hypotenuse. So we're having it as 1, this adjacent, adjacent opposite rather. Adjacent, opposite adjacent. So opposite adjacent. So that is root 3 over 1, which is equal to root 3. So that is our tan. Tan is opposite adjacent. So opposite adjacent. So 30 opposite adjacent. So 1 over root 3. So here is how to deal with these special angle. So these are all special angle in their solved form. So if you now look at it, you will see how we can now use this one now in solving these two questions. So like that. Now, because I still need some of this, let me clean this page to solve the question. Let's solve this question now. Now, solving this first question. The question says, find, let's look at this from here. So this question is saying, find the sum of y and x if tan y equals to cot x. So I'm looking for to solve this question that tan y equals to cot x. And don't forget, in trigonometry, you have tan y is equal to cot can also be replaced as 1 over tan x. Just have to memorize this also. So cot is the same thing as 1 over tan x. So cot is the reciprocal of tan. So which is we're having this. So now what angle can we now choose whereby x will be inverse of what, or y will be inverse of x? If you look at all these special angle here, let's look at it. Because I'm dealing with tan, if my y is 45, which is 1 here, What other tan gives 1? You see, there's tan here, tan 30, there's no 1, tan 60, there's no 1. So now I'll come here. If tan is if tan is 30, that is 1 over 3. That means if y is 30, 1 over 3. So equals to, and tan 60 is 3, which is root 3. Root 3. You can now see that for y to be 30, which will now give me, if y is 30, tan 30, and x is 60, 1 over tan 60. So this one gives me from special angle 1 over root 3, because tan 30 is 1 over root 3, equals to 1 over tan 60 is root 3. Tan 60 is root 3. Now see that this one equals to this. It means that my y equals to 30 and x equals to 60. So the sum of two of x and y will give me 60 plus 30. So the answer is what? Is 90 degree. So the answer is 90 degree. So that is how you deal with it. So you can see all this type of question, it jams a lot, or it puts you UTME. So when you are solving this kind of question and you are given to find this, what you use, let your mind come to special example. It will help you out to deal with that. So that is that. So now let's now solve the this question, the second question. So then I'll call it the. So now the second question says that sine square s plus sine square s plus 1 over 6 equals to cos square x. So and we have to look for sine x. So in this case, I'm going to show you another thing that you need to memorize. In trigonometry, there's what we call sine, the proof, the law, which is sine square x plus cos square x equals to 1. So you have to memorize this. So it will help you out. So if sine square x plus cos square x equals to 1, and I need to eliminate cos square x because I only need to find sine x. So to make it simpler, the first thing to do is to first eliminate cos square x. So to eliminate this, I will make cos square x the subject of formula here, then put it into this equation, then I will have sine square x left. Making cos square x the subject of formula, cos square x will be equal to, this is 1. When this one moves to this side, become minus sine square x. So if that is the case, this sine square x now, you now replace everything here with cos square x. So this question become so this one now becomes sine square x plus 1 over 6 equals to, instead of me to write cos square x, I will replace it with 1 minus sine square x. So I'm having 1 minus sine square x. So if you collect terms now, we have sine square x plus, because this is minus 1, it come here become plus, sine square x become 1, this one come to this side become 1 minus 1 over 6. So this one become 2 sine square x will now be equal to, the SN for the 2 is 6, and I have 6 minus 1. That gives 5 over 6. Now, for me to now have only sine square x, so sine square x divide through by 2, I will now have 5 over 6 multiplied by 1 over 2, which is the same thing as dividing both sides by 2. If you multiply this by 1 over 2, multiply this 1 over 2, 2 cancel 2, you are left with this. At the end of the day, this will give me equals to 5 over 12. So if I now say find the square root of both sides, you will now say sine s will now be equals to square root of 5 over 12. So that is the answer. The answer to the question is square root of 5 over 12. So these are some of the things that you need to know. That in handling this type of question, the first thing deals with special angle. Here too, you can, for me to find sine s, so I have to recall this formula, this law that says sine square s plus cos square s is equal to 1. So from there, now eliminating, if I'm to find cos s, I will eliminate sine x. So in that case, I'll make s sine s squared the subject of formula. Since I'm to look for sine s, so I'll find a way of removing this, turning the whole equation to sine and some constant number. Then making cos s squared the subject of formula is by putting this to this side. So I'm having 1 minus sine s. So it's from the